Good afternoon. I welcome all the participants to this webinar. And my name is Pietro Piffanelli, and I will chair this webinar. The topic of the webinar is GMO tools for the representativeness of the field trial sites. Please, following slide, thanks. And here's just an outline of the webinar agenda. So I will just give you a few general information about the topic and about some technical arrangements. Then I will give the floor to my colleague, Giacomo De Sanctis, who will then illustrate the topic of today's webinar. As you can see from the slides, there will be some general principles and then a live demo of the GMO tools. And then we kept 30 minutes for a Q&A interactive session and just to draw some conclusions. To the Q&A session, there will also be contributors from the GMO unit, which are Andrea Gennaro and Franco Marianeri. Next slide, please. So I've already introduced the presenter, the Q&A contributors, and the moderator. I wish to remind you the goals of this webinar, which are really to present what are the publicly available tools that EFSA developed to facilitate the stakeholders on the selection of the field trial sites and the evaluation of their representativeness. I would also like to draw your attention that out of the scope of this webinar, there is the discussion about the requirements regarding the field trial site selection and their representativeness. Please, next slide. So before I give the floor to my colleague Giacomo, I would like just to remind you that, of course, you are automatically connected to this audio broadcast. It's a one-way audio, so you will be on listen-only mode. However, you can submit questions throughout the webinar, which will be then considered during the dedicated Q&A. You can pose the questions using the Q&A tab, which you will find at your top right. The webinar, of course, is in English only, and the questions should also be submitted in English. And I would like to remind you that some of the questions will be answered in written form. Some others will be answered live by my colleagues. If some of the questions will remain unanswered, you can resubmit them via the Ask a Question Connect EFSA tool, of which we indicated here also the link. Finally, I'd like to remind you that this webinar is being recorded. So with that, I pass the floor to Giacomo for the presentation. Thanks.
Thank you, Pietro, and good afternoon, everyone. I will start my presentation with an outline of the main topic to be discussed today. First of all, I will present the objectives of the webinar. Then I will introduce the topic and talk about the general principle related to the field trial site selection for application on genetically modified plants for food and feed uses, import and processing. After that, I will present how in practice the GMO panel assess the representativeness of the selected field trial sites and their crop management practices. Then A live demonstration of the GMO tools developed by EFSA will be presented. At the end, we will conclude with some final considerations and with the questions and answers session. First objective of the webinar is to share information on how the representativeness of the field trial sites and their management practices are assessed by the GMO panel for application on genetically modified plants for food and feed uses, import and processing. The second main objective is to present the updated GMO tools, in particular the two macro Excel files will be presented through a live demonstration. It is important to mention that the use of these tools is not mandatory for applicants, but it is strongly suggested as these tools are designed to facilitate the submission of some agrometeorological data, as well as speed up the EFSA assessment. To introduce the discussion of today, I wanted to stress that an important pillar of the risk assessment of genetically modified plants is the agronomic, phenotypic, and compositional characterization of GM plants. The agronomic, phenotypic, and compositional data are analyzed through a comparative assessment to identify similarities and differences between the GM plant and the comparator. This step is the so-called comparative analysis. Those data should be collected from plants grown under agro-environmental conditions which are representative of possible receiving environments in which the GM plants can be grown. To do that, some minimum requirements were determined by the GMO panel for the experimental design of the field trials. A minimum set of 8 sites, 1 GM plant, 1 comparator, 6 reference varieties with at least 3 per site, should be established in a randomized block design. Those are the minimum requirements needed to extrapolate the conclusion produced under conditions different from those tested under a specific application. However, those minimum requirements might not be enough to satisfy the legal requirements in terms of representativeness of the field trials. That is why an appropriate selection of the sites where the field trials will be established is so important. Indeed, the Regulation 503 from 2013, as well as the guidance for risk assessment of food and feed from GM plants, state that the selected field trial sites should reflect different agrometeorological conditions under which the crop will be grown. In addition, they also report that the rationale for the selection of the field trial sites is relevant and should be described by the applicant. In 2015, the GMO panel published another guidance entirely dedicated to the agronomic and phenotypic characterization of genetically modified plants. In this guidance, more details were introduced in relation to the representativeness of the field trial sites. In particular, it was introduced the concept of diversity of the selected receiving environment, defined by a set of factors using quantitative information. In addition, it was also reported that to guarantee a sufficient diversity among the selected field trial sites, some of them should be chosen outside the sub-region representing the most typical areas. This practically means that even if it is impossible to select field trials covering all the possible receiving environment, at least some sites should be selected in areas characterized by suboptimal condition for the specific crop of the application. The 2015 guidance also provides a recommendation on how to select and manage the field trials and which are the information needed to support the selection of appropriate sites. So the key factors to evaluate the representativeness of field trials are the geographical location, the adaptability of plant materials, meteorological and climatic data, soil characteristics, crop management practices, and also exceptional weather events. Based on the experience in risk assessment built in the last year by the EFSA GMO panel, EFSA developed some tools to facilitate the submission of some agrometeorological data and to support the assessment of the field trial sites. This table summarizes some characteristics of the previously mentioned key factors. First of all, it is important to mention that some of these factors might facilitate the selection a priori of representative sites based on stable characteristics. This is true for the geographical distribution of the crop, the adaptability of plant materials, the historical climatic data and soil characteristics. Some other factors and instead year-dependent or under the human control. Therefore, it is not easy to or even impossible to predict a priori their values. However, they are very relevant for the assessment conducted a posteriori. In addition, the table is also reporting some indication on how to define optimal and suboptimal conditions for each factor. Specific field trials map might help to identify optimal and suboptimal conditions for the geographical distribution of the crop and the adaptability of plant materials. This concept was largely addressed in the guidance for agronomic and phenotypic characterization of GM plants. Whereas for climatic information, methodological and soil characteristics, as well as crop management, some GMO tools were developed to help on the identification of optimal and suboptimal conditions. Then the exceptional weather events are of course connected with the meteorological condition and usually represent unfavorable condition for the crop grown. Therefore, it is more a yes-no approach related to the present or not of the event. Talking about the geographical distribution of the crop and the adaptability of plant material, I report here an example in these figures, a map overlapping the geographical distribution of the field trials and the harvested areas might be produced to identify optimal and suboptimal conditions. The same could be done also overlapping the map with the yield per harvested areas. So basically the typical region are of course where the crop is largely cultivated, optimal regions where the crop produces high yield, which means low limiting factor. And those sites are visualized in green. Whereas suboptimal regions might be intended as the area outside the main region or characterized by lower yield. And those are as reported in yellow. As you can see, the two different maps are quite similar, as the farmer used to largely cultivate a crop when he produces high yield. But it is not always the case, and in some specific regions, you might have large area cultivated with a specific crop, even if the yield is at a lower level, due mainly to some limiting factor. This is just to show that the definition of suboptimal regions is not always a black and white. but you might have different degrees of interpretation. The crop distribution might be also overlapped with the adaptability of the plant materials to different maturity zones. In this example, we are assuming a GM event introduced into a maize hybrid with a crop relative maturity of about 110 days. Just to clarify, the crop relative maturity is an indicator to express the days needed for a variety to reach the physiological maturity in a standard meteorological condition. So overlapping in different maps, the different maps with the maturity in zones, we could identify the optimal region. That the optimal region are also related to the maturity group of the selected materials. And some optimal region might be identified outside the most adapted region for the specific crop varieties. Now, I will present other key factors as the climatic information, the soil characteristics, and the meteorological condition for which EFSA developed the GMO tool called Weather Soil Site. Our assessment of the climatic information and meteorological condition is based on the land suitability approach developed by FAO and implemented by Sis et al. in 1993. This method foreseen that for each crop, each climatic characteristics is divided into a different classes according to a rating scale from 0 to 4, which are indicating the potential productivity of the crop from 100% to 0%. As an example, in this specific case, we have the different ranges of cumulated precipitation during the growing cycle of maize. The first one represents the optimal condition, then characterized by basically in which where the potential productivity is close to 100%. Then the near optimal areas characterized by sun limitation for the crop growing. Then suboptimal and marginal areas with the increasing limitation up to the non-suitable areas where the limitations are extreme. Then the value of the table were converted on this graphical representation in which we attribute different colors for each of these classes. So dark green represent the optimal ranges, light green the near optimal, yellow for suboptimal, brown for marginal, and black for not suitable ranges. Another important aspect to mention is that among all of the climate characteristics reported in the table, we select 3 characteristics, which are average temperature, average and minimum temperature, and precipitation cumulated during the crop growing cycle. This is because we consider these characteristics the most important factors, but also because those are the data provided by the applicants for the selected field trials. This is just an example with 2 contrasting situations. The numbers represent the different values obtained for each field trial sites submitted through a specific application. So on the left, we have one case where the meteorological condition could be considered representative. They are characterized by enough variability as both optimal and suboptimal condition in terms of temperature and cumulative precipitation are recorded during the growing cycle. On the right side, we have quite an extreme situation in which we have very large variability, but in several cases we are out of the limit where the GM plant will be typically grown. As I said, this is a quite extreme situation. However, it is an example to clarify that we want to avoid to receive field trial sites characterized by conditions out of the limits where the GM plant will be typically grown. Here is how we evaluate the soil condition, and the same principle is applied also in this case. So the selected characteristics in this case are the soil texture, represented by the soil triangle, expressing the percentage of clay, silt, and sand, the organic carbon, and the pH in water. Again, another example with two contrasting conditions. In the left side, we have a good case where the soil characteristics are representative, variable, but inside the limits where the GM plant will be grown. On the contrary, on the right part, we have a situation where all the soil characteristics of the different sites are very much concentrated. So in this case, we are missing sufficient variability among the field trials. Therefore, we cannot consider the selection of these field trials representative of the receiving environments where the GM plant will be grown. Of course, this is really a simplification, as we could get thousands of intermediate cases where the situation is not that clear. And for these situations, a component of expert judgment from the GMO panel is key to evaluate the specific cases. So all this diagram based on the suitability concept could be easily produced through the GMO tool with the Excel macro developed by EFSA weather soil sites. I will show you later through the live demo how to insert the data needed and how to produce very quickly those diagrams. Now I will talk about the crop management practices for which EFSA developed the GMO tool sowing and harvesting date. The GMO panel evaluate several crop management practices applying the selective field trials, like planting and harvesting timing, herbicide treatments, fertilization, irrigation, tillage, and so on. It is important that all these crop management are typical of the areas where the field trial sites are situated. In particular, EFSA developed a tool able to reproduce crop planting and harvesting figures, representing the most active and less active periods of planting dates for each country, against the actual planting applied in the field trial selected by the applicant. And same approach is also used for the harvesting. Just to clarify, the green area represents the most active periods when between 15 and 85% of the crop is planted and harvested. The yellow represents the less active periods of planting and harvesting, and this is a specific crop for a specific crop in a specific country of the United States. So the beginning and the end of the yellow areas indicate where planting and harvesting are about 5 and 95% complete. The black lines instead represent the actual dates of planting or harvesting applied at the field trials. So in this case, we are well inside the typical period of planting and harvesting, so those crop management could be considered representative of the receiving environments. Unfortunately, we have some limitation on this approach because we retrieve from USDA the data only for United States, at least at this level of detail. And it is not so easy to find similar data for other countries, again, at the same level of details. It is important to keep in mind that, of course, the timing of planting and harvesting might also have serious impact on the meteorological condition during the crop growing. In this case, it is quite clear that the actual planting are outside the typical period. In general, a late planting, particularly for summer crops, could have an impact on the harvesting timing and or on the meteorological condition due to a shift on the crop growing cycle to a cooler period. The last factor is the exceptional weather events. An exceptional weather event is defined as a meteorological dataset falling outside the range of climatic conditions normally occurring at the selected sites. If one exceptional weather events like drought, frost, windstorm, and so on occurred at one of the selected field trials, the date, duration of the events, and crop growth stage of the plant in BBCH scale must be reported by the applicant. In case of no major impact on plants, the field trials could be used for the comparative analysis without problem. If major impacts on plant are recorded, the field trials negatively affected might be partially or totally excluded. It is important to mention that exceptional weather events are more and more frequent under farm cultivation because of climate change. So exceptional weather events are considered an important factor on the assessment of site representativeness. Most of the exceptional weather events are visually detectable through the meteorological charts produced by the GMO tools. This is quite important because it could be useful to avoid requests of clarification to applicants. A limitation of this approach is that a standardized method to identify exceptional weather events is currently missing and probably needed in the future through further improvement. So in conclusion, those are the key diagrams used to evaluate the representativeness of the field trial sites selected by the applicant. As shown in this presentation, the evaluation of site representativeness is based on multi-factor assessment. And these graphical tools could facilitate the expert judgment, making decision more transparent and repeatable. However, it is also important to mention that there might be an incredible number of different combinations of these key factors. Therefore, the evaluation of site representativeness always requires a component of expert judgment. So now we can switch to the tool, and I will start from that you can find from this link. I will start with the live demo of the Excel macro-enabled weather soil sites. So this Excel workbook is structured in different sheets. And I will guide quickly through the different one to show what the user should do to produce the pivot tables, the charts and diagram to visualize the meteorological climatic information and also soil condition of the field trials. So in this first sheet, we report an overview of the workbook and also some really detailed instruction. But let's start from the site 1. Here you have a pre-filled, let's say, information on 12 sites, and starting from site 1. What the user should do is to fill in the green area. basically. So starting from the site code and the sowing date, and then to copy and paste basically the temperature and the precipitation and the irrigation of each site. Just to make an example, if you change, for example, here the sowing date, you automatically it is changed the starting of the file. Let's say when the sowing date is fixed in the field trials, and also the chart with the daily weather information, it's automatically updated. Then what you have to do is to refresh the pivot table to update the information, and also with a double click in the horizontal axis, you fix the boundary of this chart, changing the minimum bounds with the planting date and the maximum bound with the harvesting date. And here you have this pivot table with the monthly temperature and precipitation, as well as irrigation and precipitation plus irrigation. And here you have the weekly information. And here a figure with the Tmax, T average, T minimum, and precipitation irrigation at daily level. This procedure might be, let's say, replicated for all the sites that you can have, up to 12 in this case. But of course, if you want to add an additional sites, you can simply add another site here, and then you can select everything and copy and paste in the new sheet with site 13. The only thing that you have to do here is then you can change the name, of course, and you start the same procedure as before. The only thing you have to do here is update the data sources of the pivot table, and the same for the graph. So you need to go, in this case, in the change data sources and change on site 13, and this is automatically done with the new data. And the same apply also with the figures, with the chart here, to change in 13 all the source for the figures. Then we can go to the historical data sheets, where this is all green, so the user should fill in this information with the monthly temperature, max, minimum, and precipitation. Those are historical climate data. Also, it is important to report the information when the typical growing season for the specific crop is for each of the site, and also the years of data for the climatic series. Then also a summary of the historical data. It's needed to be reported here from the user. Again, it's a green area, so the user should fill in. Those are the information, of course, that are during the typical growing season. So that's why it is important that you put here May, October, for example, for this specific site. And when you do the average of the temperature, you should do it from, of course, from May to October in this case, and the same for the cumulated precipitation. Then here we have the summary of the growing season, where this there are some simple formula that calculate basically already the average temperature, maximum, and minimum and precipitation for irrigation from the sheets of the different sites. So this is automatic. Then we can go directly to the sheet where the macro is inside. So here you can insert the soil characteristics, so the soil texture and the pH and organic carbon from these different from the different sites. And here you basically copy and paste, the user should copy and paste the information that we have in the summary historical data and the summary growing season, and copy and paste in this part. Then, of course, it's important to pick your specific crop, and then you can just click plot wall lists, and here you have the results with the figures explained before based on the suitability concept. This is this is the same as for the soil and from the meteo, which are the climatic information, and the meteorological information during the crop season. Other two important feature of this macro is that you can change basically the color of these cells. Let's say in case you want to show, for example, that one site was excluded, you can use, for example, the red, or whether there are some sites that are irrigated and might be in blue, or even maybe you want to show that some sites were used only for the agropheno analysis, and only a subset of some other were used for the composition analysis. So you might show that some sites, these two sites, were not used for the compositional analysis. Another feature that you can use, it's also let's come back to no fill. Another feature that you can use, you can also select some of the site that you want to show. Again, it might be maybe a subset of field trials used for the compositional, and you just plot the selected cells. And in this case, you have only the sites. It is shown only the sites that you select, both on the soil and on the meteo. Yeah, this basically concludes. Another feature that I want to show is basically that you can change, of course, the crop here and plot again. And of course, what is important to mention is that the characteristics and the optimal and suboptimal condition are related to the specific crop. So in this case, if I put cotton instead of soybean, you can see that, of course, basically the characteristics, the climatic characteristics, more than the soil characteristics, are out, let's say, of the limits in some case. Yeah, that's all from the first tool, which is the weather, soil, and site. Now we can go to the second tool, which is the tool for the Excel sowing and harvesting dates. For this tool, the user provides date and location of a set of field trials. This is done in the sheet input. Then activate the macro, generating a graph in the sheet output, where the dates are shown overlaid with the most typical sowing and harvesting period for the relevant US countries, based on the data reported by the USDA as I explained before during the presentation. So in this case, it's much more simple, let's say, and very quick. So you basically choose your crop, you insert your state or country. This again, it's only done for the US. Then you insert the sowing and harvesting date, and then you select what you want to show, and you just click on plot range, and then you have the figures with the, as explained before, the actual planting date versus the most active and less active periods of planting, which is specific for each crop and each country of United States. Of course, also in this case, if you change the crop, you might have different, you need to select, you have different, let's say, situation. In this case, of course, we can see a delay in the sowing planting and also a delay on the harvesting planting because the change of the crop, of course, just keeping the same sowing and harvesting. And for cotton, changing in cotton, of course, it's even more extreme, just because there are some sites, some countries, let's say, reported before in which the cotton is not even cultivated there. So in this case, you can get some error. So this concludes, let's say, the live demo for the two tools, and we can come back to the final consideration. What is important to mention is that field trial site representativeness is fundamental to draw any conclusion on the comparative analysis of GM plants. We have seen that the GMO panel takes into account multiple factors to assess the representativeness of the field trial sites, and that some level of expert judgment is needed in this kind of assessment. So EFSA developed the GMO tools to facilitate the applicants in the selection of representative field trial sites for import and processing GM plant applications, and in the identification of the information to be reported. In particular, this might be very useful to reduce the number of requests for clarifications. EFSA developed the GMO tools also to facilitate the GMO panel to make the assessment more transparent and consistent, and most importantly, to speed up the risk assessment process. EFSA and the GMO panel are aware about some limitation of the GMO tools. In particular, some important crops are not covered by this approach, like, for example, the oilseed rape. And most of the data used in these tools are available for United States, whereas data from other countries are often scarce. However, beyond the risk assessment of GMO, we can say that GMO tools may represent a first step towards more sophisticated methods to select field trials that are representative of a large geographical area. The method to assess the field trial site representativeness are under constant improvement, keeping always in mind that the main goal is to speed up the GMO risk assessment. Just to coming back quickly the problem of that some crop are not covered in the for the approach used, we can go back to the weather soil site macro, and you have also this feature to use other crops, for example, for oilseed crop, and then if you plot here, in this case, you might still have let's say the figures, the diagrams without the colors, because this is not included, let's say, on the CIS et al. Publication. So we could not retrieve information about oilseed rape and also for eventually other crop. But this is still important because, okay, you cannot see the optimal and suboptimal, but you can still evaluate, let's say, the variability among the different sites. Okay, this concludes my presentation. So now I can give the floor to Pietro for the question and answer session.
Thank you, Giacomo. Thanks for this presentation. I think was exhaustive of these new tools and describing, the current approach on evaluating field trials. So we now open the Q&A session. I'd like to remind you that you can write a question in the Q&A part of your screen, on the right part of your screen, and then my colleagues will then reply to these questions either by writing in the chat or by live, so in orally reply. We wait a few minutes that you elaborate your questions. I see already Andrea replied to the question which was addressed at 4:47. But I would like, maybe to give the floor to Andrea for some further clarifications, please.
Thanks, Pietro. Yes, indeed, we received a very interesting question already, and it's a pretty, I would say, common situation that we face several times. So the question points out to the case where, as a rescue, more than 8 field trials are planned and so and carried out. But of course, for budgetary reason, it is not possible for the applicant to carry out the composition analysis of all the sites. And so in this case, it was requested if it's possible to reduce to 8. Yes, this is frequently the case. So far, we face the situation in many cases. So it's a common practice to plant more than 8 sites, because indeed some adverse effect that can compromise the crop may occur. And so indeed, we think that is a very good strategy to plant more. But then at the moment of selecting the sites for the composition analysis, it is very important to run a similar exercise as the one needed for the original setup of the field trials in order to guarantee that the subset is still representative of the conditions. So the answer in brief is yes, it is possible and needs a proper justification. Hope this clarifies. I give back the floor to Pietro.
Yes. Well, thanks, Andrea, for this clarification. And we're waiting to see if there is any further question to be addressed. I see there are some questions coming up. Yep. I see one question. Maybe am I allowed to publish it for the moment? Can I do that? And yeah, ideally, I would ask my colleagues if possible to reply. Yes, I would give the floor to Franco, please.
Yes, thank you, Pietro. So the question is if EFSA is checking for the representativeness of field trial locations using these tools before an application is declared complete. So I think the question is referring to the completeness check of an application before the application is declared valid and the actual risk assessment starts. So in this case, the answer would be no. This is not part of the completeness check, it's part of the risk assessment. Representativeness is checked after the application is declared valid and during the risk assessment. However, during the risk assessment, after validation, the EFSA GMO panel is indeed using these tools, among others, to check for the representativeness of field trials and to decide if the field trials submitted are acceptable and adequate for the comparative analysis. I hope the answer was clear. I pass the floor back to Pietro.
Pietro, may I add something?
Yes, please. Giacomo.
Yeah, no, Franco is completely right. Just want to add that now it's probably the applicant that can check through the use of the tool could check the representativeness before to submit an application. That is the added value, let's say, of the GMO tool. But of course, EFSA has correctly said, Franco will start to check the representativeness during the risk assessment. Thank you.
Yeah, thanks, Giacomo. Thanks, Franco, for these clarifications, which are very important to guide, the applicants in the most appropriate way, also in preparing for the submission. We're waiting still a few minutes to see if there is any other question from the participants. do not hesitate, because it's a very good opportunity to have our scientific officers, expert in this area, live today. I see no questions coming up. So at this point, I would ask Giacomo, please, to move on to the next slide. So this slide is just to remind you that a LinkedIn group was created really to interact in a most productive way with the applicants. Also, using this professional social network. And of course, we invite you to visit this LinkedIn group. There you will find a lot of information, updated information on, of course, training material, upcoming events, but also on the most frequently asked questions. And as you know, now the post-transparency is live. So there are a few changes in the submission of the applications. And so please, you can use also this tool to address questions. So it's really a space that we see for quick interaction with the applicants. Here there is the address. Please, Giacomo, the next slide. Okay, so at this point, I really would like to thank all the participants to take part to this webinar. I would like to remind you that should you have any specific question relating to the topic of today's webinar, you can send this question via the Ask EFSA, the Ask a Question web form in the EFSA Connect platform, and that will be then taken care of. I would also like to remind you that the recording of today's webinar will be available on the EFSA website in the coming days. And I would kindly ask you to take a few minutes just to fill out the evaluation form that you will receive in your inbox shortly. It is indeed very important for us to have your feedback to improve our future webinars and make them as informative and productive for all applicants. Please, the next one. Okay, so here's just an overview on how you can stay connected with us. There is a newsletter, there is a Twitter account, we already mentioned the LinkedIn, and also, of course, for the one interested on joining us, there is also job alerts. Please, the next one. So the last slide is to remind you that soon, between 21st and 24th of June, EFSA will organize online and physically in Brussels a large conference called One, where, as you might see from the program, there are health, environmental, and societal issues being tackled with a large sets of international experts taking care to that. So at this point, again, I would like to thank all of you who took part to today's webinar. The link to the tools which were shown live by my colleague Giacomo are indeed already available in the EFSA website. And at this point, I wish to thank all of my colleagues who took part to this webinar, to all of you participants, and I would like to close this webinar and wish you all a nice evening. Thanks very much.